Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous two lectures, work, potential and kinetic energy. In this lecture, we are going to discuss about law of conservation of energy and see the definition of law of conservation of energy and then see how this law of conservation of energy is valid for an isolated system, for which we will discuss a free fall body under gravitational force, and after learning all these things we will solve one numerical problem. Okay, now time to see definition of law of conservation of energy. Okay, so now law of conservation of energy. This law states that energy can neither be created nor destroyed. Okay, it can only be transformed in one form to another form if we take all kinds of energy in universe and sum up, then energy is always constant. Okay, now this law is also valid for isolated system when no force acting on system from outside. Okay, so see guys, this statement transformation of energy. Okay, suppose we have a torch here and there are two cells inside this torch, or this one is a switch. Okay, now this is filament. So what's happened here, when you on the switch of the torch, then it produces heat and light. Okay, when the filament heated up. Okay, so you can say here chemical energy is converted into, guys, heat plus light energy. Okay, so guys, one query arises in your mind, where is sir chemical energy? So chemical energy is guys inside the battery. When you on the torch, then filament of this one heated up and light is produces. So this chemical energy is converted into heat plus light energy. Okay, so next guys, see this one. This law is also valid for isolated system when no force acting on system from outside. Okay, so when we consider our earth system, okay, or we consider here a free fall of body under gravitational force, then it is an isolated system when we ignore outside force due to air resistance, then this law of conservation of energy is valid. Okay, so see this one. So free fall of body under gravitation. Okay, now see this one is a ball or this one is our earth. Okay, now suppose this ball has mass m and its position is here A. Now suppose this ball travel at a distance h, then reaches to ground. Okay, or you can say in other words, the ball is at height h from ground surface whose mass is m guys. Okay, now the law of conservation of energy is valid for this one also. See how when we talk about this ball at this position, then some of the potential and kinetic energy at point A equal to guys what's UA plus KA. Okay, where UA is potential energy of ball at point A. Okay, and KA potential energy of ball at point A. Okay, so guys, in physics the other term for this one is mechanical energy. So you can say the sum of potential energy and kinetic energy of an object is called mechanical energy, or you can also define energy possessed by an object due to its position and motion is called mechanical energy. Okay, so when we apply here law of conservation of energy, then throughout the fall of this ball whose mass is m from here to ground surface must be constant. Okay, see, if we consider a point P here, okay, so then what we write for this UA plus KA, okay, so we here make a term here mechanical energy at point P. So as per definition of this one, sum of the potential energy plus kinetic energy is equal to mechanical energy. Then this point, this is mechanical energy at point A. Okay, now then at point P, suppose here arbitrary or variable distance x, okay, from ground surface. So we consider when the ball travel h minus x distance from here to here, then reaches at point P, okay, or this point P is at x distance vertically from ground. Okay, so we can write here u p plus kp equal to m g x. up is potential energy at point P, and this one kp kinetic energy at point P. Okay, so suppose when ball travel here to this point, then it attained velocity v. Okay, so velocity of this ball is v at point P. Okay, so you know guys here that equation of motion, that v square equal to u square or 2as, so v square equal to 0 whole square, because initially this ball is at point A and it is in rest condition. Okay, so initial velocity is 0 square plus 2, okay, and g or s in equal to h minus x. Okay, so v square equal to 2g h minus x. Okay, now if we put here, then mg x 1 by 2 here h minus x, or multiply by g, 2 cancel out, again mg x plus here m g h minus mgx. Okay, this cancel out, so this is equivalent to mgh. Okay, now at point A, here potential energy is mgh plus 1 by 2 mv square. Okay, so initially when the ball is at rest condition, then what's happened, velocity is 0. So we can further write mgh plus 1 by 2 m or 0 whole square. So this is coming only mgh. So what you see guys here, that initially the ball has total energy is mgh, and then after traveling h minus x distance from here to here, its energy is again mgh. So it fulfills the law of conservation of energy, means whatever the energy of this system is initially, after passing time, or you can say traveling distance h minus x, is its energy is also mgh. Okay, so you can say, sir, mechanical energy at point A equal to mechanical energy at point P, which is mgh. So guys, this proves the law of conservation of energy. Okay, now guys, see one numerical problem for your better understanding. Guys, a question is here: a ball mass 2 kg thrown up vertically with 392 joule from ground. Find highest point attained by ball. Okay, so solution guys, if we apply law of conservation of energy, so initial energy of ball must be equal to final energy of ball. Okay, so suppose this is earth, or the ball is thrown in up direction from ground. Okay, or it is initially at point A, and after traveling distance h vertically, it attained point B, where v is final velocity, which is equal to 0. Okay, so what is the initial energy of ball at point A is 392 joule. Okay, now final energy of ball at point B, okay, equal to sum of the potential energy plus kinetic energy. Okay, so potential energy m g or h plus 1 by 2 mv square. Okay, we can further write it is 2 9.8. H is the highest point attained by the ball, 1 by 2 into 2, or final velocity is 0, so whole square. So this is equivalent to 392. Okay, so this 2 cancel, or 0 term, so 2 into 9.8 into h, or 392. Okay, so h equal to 392 divided by 2 into 9.8. So this is 196, or 1, or this is 20. So you get h equal to 20 meter. Okay, so maximum height attained by the ball when you thrown up with velocity this one, it is 20 meter. We solve by the basic concept like this one. This is energy 392. So initial energy of ball is in form of kinetic energy. So this is 1 by 2 mv square. Okay, so 1 by 2, or here mv square equal to 392. So 1 by 2 into 2 v square or 392. So 2 cancel out. So v square is coming 392. So if we say v is equal to u, means initial velocity, so u square equal to 392 or u equal to under root over 392. Now if we apply the equation of motion, okay, v square equal to u square plus 2as, where v is final velocity of the ball, then it is 0 at highest point, so whole square, or u square is now 392 initial velocity. Okay, plus 2 into minus 9.8 into s is h. Okay, the highest point distance from ground surface. Okay, why here g is negative? Because see, ball is going up direction and the force due to gravity is acting in down direction. So when time passes, the speed of ball decreases, or you can say retarded, then only its value is becomes 0. Okay, so force is acting in down direction, so the acceleration due to gravity is minus 9.8. okay, then we can further write this one 19.6 h equal to 0, again 392, or this is 19.6 h, or h equal to 392 or 19.6, so 1, or this is 20, so h is 20 meter. So what you see guys, here you are getting a same result by solving this method or this method. So you can apply law of conservation of energy method for solving such type of question. Okay, or it is also easiest method. So hope guys, now the concept of law of conservation of energy is clear to you guys. If you think this lecture is informative for you and others, so please like and subscribe and share this YouTube channel Foundation JEE to your friends and family, so they also get benefit from this channel. Guys, one more request from you, those guys who have not yet been on their YouTube notification, then please on the YouTube notification, because in next lecture we will discuss about power. So whenever I upload this lecture, you will get the notification. So thanks once again watching and listening this lecture. Have a nice day. Thank you.